Hello everybody and welcome back to the Fusion 360 for FTC tutorial series. If you haven't watched the first 3 videos in the series, I recommend you do so by clicking on the card in the corner. In the last video, we finished looking at the create and modify tools within Fusion 360's sketch workflow. In this video, we're going to be looking at the sketch constraining tools, and we'll be discussing the best practices for constraining sketches. So let's go ahead and create a sketch, and almost all, if not all of the geometries we have been creating, when we create them, they have blue lines. So if I go ahead and create a circle, you'll notice that it has a blue border. But most of the geometries that we'll be creating in the future will have black lines. And the blue line means that the position and the dimension is unconstrained. So if I went and took hold of this center point for the circle, I could drag it around freely, which means that the position is completely unconstrained. So it can be anywhere. Fusion will allow it to be anywhere. If I grabbed onto the edge of the circle, we could change the size of the circle freely. Now, when I created this circle, if I had input a dimension, like we've done before, the circle size could not be changed. It could only be dragged around. So the first thing we're going to be looking at is dimensioning sketches. Now, we've looked at how to dimension sketches geometries when you're creating them, but it's possible to add dimensions after you've created geometry. So we're going to create 2 circles for our example here, and I want them to both be 50 millimeters in diameter. So we're going to go ahead and create these, and now I want the circles to be 200 millimeters apart. And how would I create that in Fusion? So I could create a line, and then I could create a line from the first circle and then create a circle here, but what I really want to do is I want to drop down here under the create menu. It's also up here. It's called sketch dimension. It's down here. The shortcut is D, and I'm going to click that, and this can be used between any 2 sketch objects. So that's arcs, lines, points. So right now I'm going to select the center point for the circle, and I'm going to select the center point for the second circle. And now you can see we've got this dimension here like we have in the circles, and it's between the 2 points. So I'm going to click to place it. This is the location. It's just going to be where it is on the sketch plane. It doesn't interfere with geometry. So I'm just going to click there, and now we can input a value for this. So if I wanted for them to be 200 millimeters apart, I could input 200 millimeters here, and now we would see they're 200 millimeters apart. And if I changed the position of this one, they would still be 200 millimeters apart. If I drag it over, they're staying 200 millimeters apart. So these are constrained, so they're constrained at 200 millimeters apart. So that's one way to do it between geometries. If we go ahead and delete our circles and we create a circle that has no dimension, and now let's say we want to add one in later, you can create one by simply clicking on the circle and specifying the diameter. So if I want this to be 150, I'd put in 150, and you can always change dimensions later by simply double clicking, and you can re-input them and change the value. If we create a rectangle, it can be done between the sides of the rectangle like this. If I just select here and here, we'll get the height, and I can also do the same by just simply selecting the height line, and it'll give me the same thing. So you can measure between 2 lines or measure a line itself and specify its length. So if I went and created this, I could say 150 by 100, and now we have that size, and we could move it, but we couldn't change the size. This can also be used in angles. If I create a line like this, and I create another line, and I don't specify the dimension here, the angle between these lines, I can go ahead and add that by clicking here and here, and now we have the angle and we can change it as we please. Now let's take a look at the circle example again, where we have two circles and we are making them 200 millimeters apart. So I'm going to create my circles, and I'm going to select the center points again, and I'm going to put 200 millimeters. Now, this is probably something you're going to run into later, but let's say I made some points on these circles with construction lines, just by going like this and going over, and going like this and coming over. And let's say we dimension the points that were created there, like this. Or sorry, my bad. If we went like this, here's what we need to do. And let's say we dimension these points that were created. This distance would also be 200. If we went to place this, Fusion 360 would give us a message. This does not mean there's an error in anything we've done, or an error will occur if we click OK. It simply means that if we click OK, you'll see that it's in parentheses and we cannot change this value. And that's because we already have this 200 value here, and it's already specifying the distance between them. So by adding a second one, we're not adding any new information. So this value is just a reference value. It's just, if you want another reference value so you can see the distance between two things, you can go ahead and add it, even if it's already constrained. If we change this one to 100, let's say, this one also changes with it. So now that we covered the dimensioning tool, let's take a look at the constraining menu over here. And all the constraints are available here, and they're also available in the drop-down. So what are constraints? So constraints are not dimensions. They don't specify length or angle usually. What they are is they specify the positioning of the geometry, and sometimes they'll constrain the length or the angle, and we'll take a look at that later. But they are the way that you completely constrain your geometry, and you make all those lines black, so everything is fixed in position and length and angle. So if we created a line here, what you may have noticed already, so if we turn this off, is if I go on this horizontal x-axis, you'll notice that we get this funny little two lines with three lines sticking out the bottom. And we get the same thing if we go up here on the y-axis. And this is the first constraint that we're going to be looking at. Often Fusion 360 will automatically apply constraints for you when you're creating a geometry if you select that. So if I place this here, we would have a horizontal constraint, and if we place it on the y-axis, it would be a vertical constraint. And that means that I can drag this as much as I want, but this line has to stay on the horizontal axis. And the same here, it has to stay on the y-axis. So that's if it's being automatically applied. If we applied it ourselves and we created a line like this, it would pick whichever one it's closest to. So if I click here, it would give it the, let's get rid of this, it would give it the vertical constraint here. And now it's always parallel with the y-axis here. And if we had made it closer to the x-axis, it would go like this, and it would apply the x-axis constraint. And by closer, I mean whichever one it's closer to in angle. So the next constraint we're going to look at is the coincident constraint. And what this does is it makes it so two things intersect each other. So if I use these two lines and I selected this line and this line, if let's use these points actually. If I selected this point and this point, it would make it so these points intersect. And now I could select this point in the origin, and it would be fully constrained, as this line is intersecting with this line, which is intersecting with the origin, and that gives it its position. So we could use this with all sorts of things. If we make ourselves two rectangles and we make the points coincide in here, then they are touching each other. If we make the this line coincide it with this point, then it is in line. So that it just makes two geometries intersect at a point that you specify. The next tool we're going to be looking at is the tangent tool right here. And the tangent tool, it makes a line or in a curve. It gives them a tangent. It makes them tangent. So if I create a circle and I create a line and I create a line, then what you'll notice is if we use the tangent constraint and we select this line and this circle, that this is tangent now, and it's only going to touch the geometry 1. So if no matter where I move this, it's only touching at one point. It's tangent to the circle. And when I create a circle and I'm making a line and I'm coming along the circle, and let's say I pick a point on the edge of the circle, what you'll notice is that we have this here, which is the tangent symbol, and if I put that at the right angle, it'll tell me that I'm creating a line that is tangent to the circle. If I click OK, then this is tangent, and it's automatically applied the tangent constraint. And again, if we move it around, it's always tangent. Same thing with the coincident constraint. If I had created a line here at the origin and I clicked here, it would tell me that this is a coincident with the origin. So it's as much as you move this, that point is always going to stay at the origin. Next, we're going to be looking at the equal constraint, which is right here. And the equal constraint is the first constraint that we've looked at that does not specify geometry, or it does not specify the positioning for geometry. It specifies the distance or the length. So if I create two lines and create two lines like this, and let's say I'm going to make this line 100 millimeters long, and I want the other line to also be 100 millimeters long. I could add a dimension like this and say this is 100 millimeters, or what I could do is I could use the equal constraint, and I could select these two lines, and now this one is always going to be constrained by the length of this one. And how it knows which one to pick is the length that they're both going to be, is that it's whichever one is constrained. So if neither of them are constrained and we select it, it's just going to, I think, pick whichever one you select first. So that is the equal constraint. And let's take a look at the parallel constraint. It's very simple. If we create a line like this, well, let's not make it vertical. Let's make it like this. And we create another line. We can make these two lines parallel to each other by simply clicking both of them, and now they're parallel to each other. Again, if I constrained one of these, so let's use the coincident constraint, make it come at the origin. Let's give ourselves a line to work off so we can specify the angle. We select this, and we say this is 45 degrees. Now we're fully constrained, we're black. The only thing that can change is the distance of this. If we made this parallel to the constrained line, the constrained line would not change because it's fully constrained, and this one would in turn change. Instead of, so this is useful. Instead of constraining both of the lines and specifying the angle, we could have done this and also give it 45 degrees. Instead, we're using the parallel constraint. Let's get rid of all of that, and let's take a look at the perpendicular constraint. You're probably familiar with what perpendicular is, but it's a 90-degree angle between two lines. So if we created some lines, let's turn this off, and we wanted to make these perpendicular, the first thing I'm going to do is just make a coincident constraint. So they're touching and we can see it clearly. I could create a angle dimension between them and set this equal to 90, and now this angle is always the same no matter where we move it. Or I could use the perpendicular constraint and make these perpendicular to each other. And that's generally better than adding a dimension, is using the proper constraints. And we'll talk more about that later in this video. Next, we're going to be looking at the midpoint, which is this triangle here. And this is probably one that you're familiar with if you've ever created a line like this or anything, and you go here in the middle somewhere, it'll give you a lock here, a little magnetic snap. And that's a with the triangle with the X means that you're at the midpoint. So if I went and created this line, I'd not only get the perpendicular constraint because I made it 90, I would also get the midpoint constraint because this was created at the midpoint of this line. Now you can do the same thing by just creating a midpoint. So this is at the midpoint of this line, this point, and now we've got it at the midpoint. And that's basically it for the midpoint. It's very simple. Let's take a look at the concentric constraint. And this can be used with 3 different geometries. It can be used with the circle, the arc, and the ellipse. All of these have center points. And so if we just take a look with the circle for an example, and we create a circle like this, and now let's say we create another circle and we want this smaller circle to be inside and it's sharing the same center point, we could use the concentric constraint. We'd select this circle, we'd select this circle, and now we have them concentric. The same thing can be done with arcs. If we create a 3-point arc like this, and we give ourselves an arc, and we create another 3-point arc, we could use the concentric constraint like this, and now the arcs are concentric. Same thing can be done with ellipses. If we make ourselves some ellipses like this, and then we use the concentric constraint, now they are concentric. It's very simple. Can be used with those 3 geometries. And next, let's take a look at the collinear constraint, which is right here. And the collinear constraint makes it so that 2 objects share a common line. So if we just show a simple example with some lines, and we go like this, and we use the collinear constraint, you'll notice that they now share the same line. And this means that they are they're not only parallel, they're on the exact same line. So they're intersecting at infinitely many places. So that gives us the collinear constraint. If we did the same with some rectangles, let's say, if we simply, these lines would already be parallel with each other, but if we want this one to always be collinear with this one, we could use the collinear constraint, and now these would always be collinear. No matter what dimensions we change, they will always share that same top line. So this can be used with many things. Next, let's take a look at the symmetry constraint. And this is our third to last constraint that we're going to look at. So the symmetry constraint simply makes it so two objects are symmetrical over a axis. So if we create two circles, and now we create a line for them to be symmetrical over, like this, we can use the symmetry constraint. And we first select the first object, then the second object, and then the line that they are symmetrical over. So now they are symmetrical, they have the same size and same position relative to this middle line. So if we move them around, they will stay the same size, and we can change the size and they'll stay the same. They're always the same position relative to that. And we can change either one and they'll both update. So if we wanted to add a dimension here, and we made this 500, they would both change and we wouldn't need to add another one here. If we did, we would get that driven dimension pop up. So if you want to create a reference for the symmetrical objects, you could. And if we just created a distance like this, and we changed it to 500, let's say, now they would both be 500, and they could just move up and down, and we could finish fully constraining it by putting the vertical distance here, and if we also made that 500, now we're fully constrained. These can't move, and we only constrained one side and the other one's constrained. So it's very useful for just simplifying stuff when it's symmetrical. And next, let's take a look at the curvature constraint. So the curvature constraint is kind of a mashup of the tangent constraint and I believe what's called a G2 curve. So if we create two lines like this, and we want to interpolate smoothly between these lines, what we could do is we could add a spline. So we'll just choose a fit point spline, and for now I'll give it 2 knots. And now we have these handles here, and even though it's a straight line, if we change these handles, we could see that it's in fact a spline. So if we use the curvature constraint here, and we selected these objects, you can select as many as you want, you would notice that we would have the, so I'll go back and redo that just to show you clearly. So I select this one, and then I'm selecting this top one and this middle one. We would have a smooth interpolation between these, and it automatically changes the position of this. And again, we have handles like this, and the spline handles have now been replaced with these blue handles, and you can move these around to change the way the shape it's interpolating. And if we looked, we could see that this is actually has a tangent constraint already applied to it. It's part of the curvature constraint, so if I went and tried to apply a tangent constraint, it would not let me. So last tool that we're going to be looking at is the fix/unfix tool, and it can be found here, or it can be found if you make a geometry and you right click on it, you'll get the fix/unfix pop up here. And this is different than the other tools. Instead of, it simply fixes in the position and dimension of something. So if I applied it to this line, you would notice it turns a different color, and we cannot move this. We can't move the position. If we applied the dimension like this and we made it 200 millimeters long, although this is not constrained the position, wait, is that applying correctly? Sorry. Yeah, okay, my bad. If we select the fix/unfix on the points, now it is constrained completely. My apologies. The placing it on the line does not fix its position. So if we place it on the points, it's fully constrained now. And instead of having to add those dimensions, like instead of placing it like this, we could have added the dimensions to the y-axis and the x-axis and specified the angle and everything. So this is a simpler way, but it's different than the other construction commands we've looked at. So now we're going to talk about the practices for constraining sketches. So when constraining sketches, the best practice is to always fully constrain them. And we'll talk about why that is in a second. So you should use the dimension tool and the constraint tools to turn all the sketch geometry black. So that's fully constrained. And the general rule of thumb, just to keep things clean, is to always use the constraints over a dimension like we've talked about before. For example, the fix, you can use the fix instead of putting the positioning. But the fix is very special exception. A better example is the symmetry constraint. You should always use the symmetry instead of specifying the position of both symmetrical geometries. If you leave the sketch blue and you go back and change some of the values, it may not update as you would expect it to, and that's because there's multiple ways it can change. So if everything is black, it's fully constrained, and you change a value, it should update as you would expect it to if you placed all the constraints properly. So yeah, use the constraint tools and the dimensions to fully constrain the size and the position, the angle of everything. So my challenge to you for today's video is to create this stick figure, and you'll notice everything is black. It's fully constrained. I have some hair up here. I have some eyes, a mouth, some arms, and some legs. So I encourage you to pause the video now, give it a try, and I'll show you how I did it in just a moment. Okay, hopefully you've had a chance to do that. So let's take a look at how you can do this. So the first thing I'm going to create is my head. It's my head for my stick man. So I'm going to do it along the long ways about so I can show you manually applying constraints to everything. So I want the head to be at the origin, but I'm not going to make it the origin. So I'm just going to place it like this, and I'm going to use the coincident constraint on the circle and place it at the origin. So now it's locked in the origin. I can change the size, but I can't change the position. I'm going to add a dimension here, and I'm going to make my head 200 millimeters. And now we've got black already. So that's good. We're off to a good start. Next, I'm going to add the eyes, and I'm just going to place them like this. Doesn't really matter. We're going to change everything up. When you're constraining sketches, you really don't have to be that careful about how you place stuff because you'll constrain it later. So I want these eyes to be symmetrical, as we talked about. Eyes are the same on either side, so I'm going to add a line of symmetry to use. Turn on the construction mode, and I'm going to add it like this. And just pet peeve, we can go ahead and use the extend tool and extend it up. Now let's choose one eye to constrain. So I'm going to use this eye to constrain. So I'm going to first apply the symmetry tool, the symmetry constraint to these, and now we've got them symmetrical. And now what I want to do is I want to figure out the positioning for all my stuff here. So instead of using the fix where you can't specify the positioning of the eyes, I'm just going to use some dimensions here. So I'm going to create another construction line here so I can measure, and I'm going to use the dimensioning tool, and I'm going to put this at 45 and I think something like 35 is good. And lastly, we just have to constrain the size of this. As you see, you can change the size but not the position. So we're just going to put this down, and I'm going to make mine 30, something around that, 30, 35 looks good. And now our eyes are fully constrained, and we've just constrained this one, and this one's constrained by the symmetry constraint. So last thing we got to do is we got to add the mouth to the face. So I'm going to create an arc like this, and I'm just going to create a 3-point arc like this, and we'll turn that back into normal construction by selecting and pressing X, and we'll turn that off for now. So I'm going to use the concentric constraint here as the middle point for the arc. I want it to be the same as the middle point for the face. So I'm going to select these, and since this one is fully constrained, it automatically moves this one. So now we've got our arc. So the things that we can change here, we can change the radius of this arc, and we can change the points of the arc. So I'm going to actually use the symmetry constraint here, and I'm going to place symmetry between these 2 points instead of actual geometries like we've done before. So I'm going to place it like this, select these, and now these are symmetrical over this line, so I can move it, but it's always staying the same. As we know, mouths on stickmen are perfectly symmetrical, so that's what we're going to go with. Now again, we only have to constrain one of these points, and it should be the same. So I'm first going to constrain the radius of my arc. I think something around 70 is good. Big mouth, and now we just have to constrain the positioning of one of these points. So I'm going to constrain this one, and I'm going to go ahead and place this at 40, and now we just have to do the X constraint, and I'm going to go ahead. Oh, we don't actually need that. That's correct, because we have this radius specified and we have this dimension specified. So it can't actually move in. So now we got our face constrained. Everything's looking good. If we want to change any of these values, we could go ahead and everything would update properly, just how we would expect it to. So we're going to make the hair now. I like my hair to be perfectly perpendicular and tangent, so that's how I'm going to make it. So I'm going to create some lines for my hair here. So I'm just going to place them arbitrarily for now, and we'll constrain it. So let's place the perpendicular constraints first. These are going to be my 2 spikes in the middle here, and these lines are going to be touching the head. So I'm going to add the tangent constraints to the ends like this, and I'm going to add the coincident constraints, this is the end of the hair, like this. And then next I'm going to add a coincident constraint to this point, and that's going to create that nice spike. Next we're going to specify, if we look here, the angle of this can change, so we're going to specify the angle of this here to the center line of the head. I'm just going to make that 45, and now we're all locked in. Nothing can change. We're good, and we got some nice spikes on our hair. So next we're going to move on to the arms and the legs and the torso. So I'm going to start by creating the torso, and we want this to be if we just pick the horizontal constraint, or the horizontal vertical, it would go like this, but what we actually want it to do is be collinear with the center line of our body. So like this, it's collinear, and now we can place the coincident constraint with the head. And now we're all touching there, and now let's make some legs. So let's place some legs down, and we want the legs to be coincident with the bottom of the torso. So we're going to go ahead and place that here, and we want our legs to be parallel. Symmetrical. So we're going to pick this, and we can pick the torso as the axis of symmetry. So if I place that, they're now symmetrical, and they're moving together. So what I'm going to do here is I'm actually going to place the, instead of constraining one of them, the angle of one of them to the center line, I'm going to constrain the angle between them, like this. And the way that this works to constrain them is that it has to be 45 divided by 2 degrees on either side. If you move it over, then they are no longer symmetrical. So it has to stay perfectly like this. And you can see the dimensions are wrong, but we'll come back to this later. We'll add dimensions once we've added the arms. So let's put some arms down here in the general positions, and let's add a coincident constraint with the arms and the torso, like this and like this. And again, we want our arms to be symmetrical, so we're going to use the symmetry constraint here, and we're going to do the same trick we did down here and just specify the angle between them, and I think something like 130 is good. And the last thing that we have to do is we have to specify the distances for everything. So right now the only thing that can change here is the length of the arm and the distance to the head. So I'm going to go ahead and start adding some dimensions here. I'm going to make this 70. Oh, did the symmetry constraint not apply correctly? Let's check that. Let's add the dimension here. Like that, it's working now. Let's do, oh, it seems to be, we can just apply, we can just make these coincide here. So if we place it like this, now it'll be like this, and we can just change this value for 1. So I'm going to make this 50. And for the length of the arms, I'm going to make it, let's say 150, and I'm going to use the equal constraint here, and just now they're both the same length. Next we got to do the torso, so just going to place this here, and I want my torso to be 300 millimeters. And the last thing we got to do is the length of the legs. So I can specify, I think something like 200, and let's just use the equals constraint. And now everything is good, and we have our fully constrained stickman. And if we change any one of these values, everything will update properly. If we want a super long torso, we can change it. And whoops, we forgot to constrain something here. This has to be coincident with this. And now everything should be good, I think. Yeah, everything's working properly. So this is good for now. We had some issues along the way, that was my fault, but hopefully you understand how to use constraints. And obviously sometimes it can be hard to troubleshoot the issues with how you have with them, but the best thing to do is just stick with it. If you think something's not working, just reapply the constraint or delete the applied constraint. So in the next video, we'll be finishing up sketching tools in Fusion 360, and we'll be looking at one tool next time, and that is the sketch parameters right here. And this is a very interesting tool, and in the video after that, we're going to be starting a project, and I can open it up and show you what that's going to look like here. Once we're done, it's going to be a screw and nut with working joints, and we're going to have some good renders with them, and it's going to be fully customizable with the parameters that we're going to look at in the next video. So hope to see you then. Alright, I hope you learned something, and I'll see you in the next video.